Welcome to episode 3 of Recreational Mathematics, some math fun to help support History of Math 11, but really the good parts version of math, so it's got some ideas and thoughts that are ready for learners of all ages. Once again, we have a magic eye. This one comes from a newspaper clipping, and if you can focus in enough, it gives you some instructions to look at the picture so that it's blurry. Hold your gaze, move in and out, see if you can see the 3D picture. Pause here before moving on. This week we're taking a little bit of a look at why we need to understand the numbers in order to solve some questions and take some different strategies and approaches used to solve mathematical problems throughout all of history. So we're going to take a little bit of a look at some strategies. We're going to see the way people visualize numbers, the flexible mindsets we sometimes need to take a strategic approach to solve problems, and see that some problems can actually be fun to work with. As one example is, there's a little game that we can play called Sprouts. Sprouts is played by two players connecting spots within lines on a playing surface. The playing surface is just dots. 3 spots are usually a good starting point. You can do more. Players take turns connecting the spots or drawing from the spot to itself and adding a new spot along the line. Now, the line must not touch or cross itself. The new spot cannot be an endpoint of a line, thus splitting the 2 lines in 2 spots, and no spot can have more than 3 lines connected to it. Eventually, there's no more legal moves, and the last pair to make a legal move wins. Now, that's the way it looks like. Here's a little video to help support what it looks like as well. So we've got the dots down, and you're going to loop some dots or loop to yourself. Any pathway that is formed, you can create another dot, but you can only have 3 branches, and that's where things get a little bit trickier and more complex. As eventually you have nowhere else for you to go, and the game is over, and we're on to our next activity. Try it with friends, explore. Now, there is a reminder I want to say that math is fun. I know many of us have sometimes been bored into doing too many questions of the same type, but sometimes playing with numbers can be fun, especially when it doesn't really have numbers going on whatsoever. Here are this week's brain teasers, 8 of them to solve. Pause it here when you think you know all the answers or when you just want to know what all the answers are. Unpause and I will reveal the solutions. Counting is an interesting thing. Channeling my inner Paul Lockhart and entering a rabbit hole, there are many different numbering systems that have been used throughout history and throughout different cultures and countries. For example, while we use 10-finger base counting quite often and have base 10 blocks, tens, hundreds, thousands, 10,000s, that's not the only way. If you want a pro tip of a rabbit hole to enter, look up base 6. And you can explore some of these other ones to see that our current decimal system is not inherently superior, but it is simply a choice. And I'm going to share with you another one that, again, if you want to take a project, this is a great one to explore. What are some other ways of showing numbers? In the 13th century, this numbering system was easily able to show any number from 1 to 9,999 using a single symbol. There are 5 down below. I will slowly reveal them so you can pause as you want and see if you can tell what the number is before we unveil it. Here is a solution to that first one. Next. Don't be afraid to pause if you want to see what's going on. Next. Next. And the final one, which is, in that 9,000 range. It's interesting how you start seeing some of the patterns as you get used to it, just like we do with all of our numbers. And of course, sometimes we need to solve algorithms, and sometimes there's going to be more than one solution, as we're going to see in just a moment. But here's the first one. How do you take 2166 to get 48? There are many different ways to solve this one. I like looking at 48 and practicing and knowing what some of the math timetables are. I know that there's a connection between 48 and 6, and that is that 8 times 6 is 48. So I can see that if I was to go 6 times 6 in that last one, that'd be 36. That wouldn't be close. I can't move the 1 to be in front of the 2 to be 12 plus 36. So instead, I'm going to have to first multiply 2 times 1 to get 2. Add that to the 6 so that 2 plus 6 equals 8. And then I know that 8 times 6 is 48. How does this mental math help? Well, it lets us play some of the other numbers that are around as well. This is one of my favorite morning games as I get my brain going. It's available on mathzone.co.uk. Oodle's fun. It gives you an answer. It tells you instead what number operations you are to use, and you have to figure out what numbers it is that you want to do in order to get to the answer. Now, the nice part is you don't even have to get to the right answer. You can throw in some numbers to start you off with just to help you narrow it down a little bit. In this case, I was starting to go with, okay, what is 8 away from 41? That'd be 49 or 33. Maybe I don't like that one so much, but I'm just going to explore a little bit, see what 30 would get to. See, not a correct answer, but now I know that 6 is in the mix. So by using the 6, I was able to go 2 minus 1, that's a 1. 6 times 7 is 42. So, not that way because I'd be going to 43. If I reverse that, 1 minus 2 is minus 1 plus 42. So 42 minus 1 gets us to that number 41. And then it tells you your time, and you can try to get faster and faster and faster. It's a nice daily activity that you can do to get your brain into a mathy kind of mode. There's another game that Channel 4 has put out. It's called Countdown. Absolutely fabulous show, and it deals with making words and figuring out numbers. Here's a little video sample of one of the countdowns.
This game for today, Reese.
Hello, Rachel. Can I have 4 from the top and 2 small, please?
You can indeed.
So 4
Thank you,
from the
Reese. 4
top
large
are
ones
big
and
numbers,
2
10
little ones. And the first
bigger than
numbers
10,
game of the
25,
week
50, 75,
is
100.
2, 5,
The littles
and
are
the large
littles.
ones, 25, 50, 100, and 75. And the target, 350.
You're trying to get 350, and you only have 30 seconds. In this case for me, when I was looking at it, I was thinking, you could just add a few of the numbers together. 5 times 100 would be 500. That's too much. What would be an easier way to do it? Teasing out, not trying to give an answer for this one. This one is fortunately a little bit more of the more straightforward ones.
Yes, Reese.
350.
Thank you, Michael.
350.
There we go. Reese.
75 times 5.
75 times size, 375.
And take off 25.
Yeah, don't think we need to write that down.
And Michael.
I've done 5 plus 2 is 7, times by 50.
Perfect, lots of different
5
ways.
plus 2 is 7,
Thank you very
times
much,
50 is
Ian.
350. So that's a nice little delightful one. Again, the nice part is you only have 30 seconds. You can't always get to it. In fact, you can't always get to the answer that the computer comes up with, and you can only end up getting close.
22. And now, Michael, it's your numbers game.
Can I have 2 big and 4 small, please?
You can indeed, thank you, Michael. 2 from the top row and 4 of the other ones. And this time around, your little numbers are 8, 1, 9, and 7. And the big ones, 50 and 75. Could be tricky. Target, 534.
534.
This is one of the ones that 30 seconds does not quite feel like enough time. And again, that's the delightful part. But you can add numbers together. So I might go 9 plus 1 is 10, times 50 to get to 500. Rachel's brilliant. She probably already has it solved right now. So at 500, I'm going to go with that. 500 minus 72 to get 528. I'm pretty close. 528 out of 534 is close.
Michael.
Nowhere near, no.
Too far. How about Reese?
534.
Well done. Let's hear how you did it.
75 times 7.
75 times 7, 525.
And then on the 9.
Yep, 534.
Swiftly done. Well done.
I don't know my 75 times tables all that well.
Days.
Now, the fun part as well is incoherency.co.uk has a practice version of the game as well.
Incoherency.co.uk has a nice option to practice countdown, both letters and numbers. Number version, I'm going to pick 3 large. I am going to see what happens. We have our big 75, 25, 100, 859. The target is 695. I am going to say 100 times 8 is 800. Minus 75 equals 7. Minus 75 equals 725. Oh, and I need to get down another 30. 9 minus 5 is 4, times 8 is 32, which gets me close to 693. But I'm not sure. I was rushed. Let's see the answers. Oh, which are 75 times 8 is 600. 600 minus 100 is 700. Minus 5 is 695. Oh, multiple ways to get to the solution. That's a wonderful thing about Countdown, and especially with numbers. The more you play with this, the faster your math facts get, and it's a little bit of fun. And of course, with this game, if you want to practice, you can change the timing, so it's not just 30 seconds. You can have longer time as well.
The joyous part about math, there is no one right solution. So, some reflections for this week. Did you see the image? Do you have any thoughts on sprouts? Did you solve the lateral thinking problems? I do like the weird math connection, like the Wizard of Oz, which reminds me of Over the Rainbow, is closely associated with Pink Floyd's Dark Side of the Moon. The music album fits very closely to the movie and creates a whole different way of viewing the film. And again, a great dive into the different types of counting and the different math systems that have existed over time. And what do you think about Countdown? There is another fun one on Channel 4 as well, but that's for you to explore as well. Those are some reflections for this week of Recreation.